Yeah guys, welcome back to another video. In this video we're going to be talking about how to look for the lowest common multiple. How to look for the lowest common multiple. So first of all, let me give you some background details. This video is going to be just 10 minutes long and we're going to be covering 3 examples where I will explain in details how you can look for the LCM and exactly what is LCM first to begin with. So for the number 2, 9 and 5, the LCM is 90, as you can see here, 90. Now why do we need to learn this? Why do we need to understand how to look for the what? LCM, that's lowest common multiple, LCM. So the reason why we need to understand this concept is because it is very important and we're going to make use of it a lot when we are dealing with addition and subtraction of fractions. And we're also going to make use of it when we are dealing with simultaneous equation using substitution method. So therefore, it is important for us to understand how to look for the LCM of numbers. For example, this 2, 9 and 5 here could be the denominator of a fraction and we have to look for the LCM. We're going to be dealing with that in subsequent videos where we're going to be talking about how to look for the what? LCM and how to do what? How to add and subtract fractions. So subscribe to see those videos. So let's proceed. How do you look for the LCM of numbers? First thing you need to do is draw your table 2, 9 and 5. So what you need to do is you have to look for any number that can go either into one of these or more than one of these numbers. So you have to look for any number that can go either into one of these or more than one of these. For example, in this situation we are dealing with, you can see that there is no number that can go into either 2 or 9 or 2 or 5 or 9 or 2 or 9 or 5. Because all these numbers are all what? They are all prime numbers that is, they can only be divided by themselves and 1. So what do? We need to take one of this number, 2 for example, or 2 firstly, 2 in 2, that will give us 1. 2 in 9 cannot go, so what do? We have to write our 9 back. So whenever the number that we are using to divide cannot go, we have to rewrite that same number back. For example, 9 cannot be divided by 2, so we write 9 back. 5 cannot be divided evenly by 2, so we write 5 back as well. You get that? So here, what do we do next? We have 9 and 5, so we can either choose from 9 or 5 to divide again. So we're going to choose 9 in this situation. 9 in 1, since 9 cannot go divide evenly into 1, we write 1 back. 9 in 9, since 9 cannot divide evenly, since 9 can divide evenly into 9, and that will give you 1, you write 1. 9 in 9 is 1, so we write 1. 9 in 5, since 9 cannot divide evenly into 5, or 5 cannot be divided by 9, we write 5 back. So what do? We have 1, 1 and 5, which means we need to do what? We need to divide by what? Any number that would what? Bring the whole number to 1, 1, 1. So when you are solving LCM, you need to divide until the whole base is constituted of 1, 1, 1. So 5 in 1, we have 1. 5 in 1, we have 1. Why do we have 1? Because of 1 cannot be divided evenly by 5. 5 in 5, we have 1. And you look for this all, you have to ensure that they have what? A common base of 1. So once we've done that, then we are set. So how do we get the LCM? The LCM we get by just multiplying what? This, and this. That is all the number we use to divide all the what? All the elements that we're given, or all the numbers that we're given to look for the LCM of. So that's why we have 2 times 9 times 5. That gives us 90. So now this 90, the meaning of LCM again is that this 90, all these numbers here, can divide evenly into this 90, which is the reason why it is very important to understand this concept, because of this is what we'll be making use of when we are solving or when we are adding and subtracting fractions. So let's go to the next example. Here we have what? 3, 9, and 12. So what do? We need to write our 3, 9, and 12 in our table. So remember, the first thing we want to do is look for either a number that can divide any one of this number, or if you observe that there is a number that can divide everything, or even just 2 out of the given number, or even that can divide, or even if you are given 4, for example, you have to look for a number that can divide even if it's 3, 2, or 1 of the number. So you can see here that we have 3, 9, and 12. And we know from our knowledge of multiplication that 3 can go in 3, it can go in 9, and it can go in 12. So we divide by 3. So let me explain that again. Once you are given a number like this, you have to first of all what? Look at those numbers. If there's anything that can divide all of those numbers, either all of those numbers or parts of the number. So either the number you choose can divide 3 and 9, 3 and 12, 3 and 9 and 12, or the number can do what? Can divide all of the numbers that you are given, that is 3, 9, and 12. You get that? So that's why we put 3, 9, and 12 here, and we divided what? We have to do what? We know that 3 can divide all these numbers, so we start 3 in 3, 1, 3 in 9, 3, and 3 in 12, 4. Do you get that? So what do we do next? The next thing we want to do is what? We have to look at these numbers again and look at if there's any number that can divide evenly into either all of this number or part of these numbers. So you can see that we have 1, 3, and 4, and there is nothing that can divide 1, 3, and 4. In that case, what you need to do is what? To use the numbers themselves to divide itself. So you have what? 3. You use 3 in 1. Since 3 cannot go evenly into 1, you write 1 back. 3 in 3, you write what? 1, because 3 in 3 is 1. 3 in 4, 4 cannot be divided evenly by 3, so we write what? We write 4 back. What do we do next? We have 1, 1, 4. Remember, our goal is to divide onto the whole thing as what? A common base of 1. So we have what? 4 in 1. Since 1 cannot be divided evenly by 4, we write 1 back. 4 in 1 again. For the same reason, we write 1 back. 4 in 4, we are going to have what? We are going to have 1. Are we together now? So what do we do next? Remember, I told you after dividing and you have the whole base as 1, what you just need to do is what? Multiply everything together like this. So we are going to have what? 3 times 3 and 3 times 4. 3 times 3, 9. 9 times 4, that will give you what? 108. So let's proceed. So this number 3, we are given what? 2, 6, and 8. And as you can see, first thing you need to know is what number can divide evenly into all these numbers, or that can divide what part of these numbers evenly. So you have 2, 6, and 8. So we have to look for any number that can either divide what? 2 and 6, 6 and 8, or 2 and 8, or any number that can even divide the whole number as a whole. So from here we see that 2, 6, and 8 can be divided by what? 2. So we start 2 in 2, that's 1. 2 in 6, that's 3. 2 in 8, that's 4. So what do we do next again? We have to look at the number we have again, 1, 3, and 4. So we have to look for any number that can divide evenly into all these numbers. So or any number that can just what? That can divide either one of the number. So here we see we have 1, 3, and 4. So what do? We know that 4 can be divided by 2. So we divide 2 in 1. Since 1 cannot be divided evenly by 2, we write what? 1 back. 2 in 3. Since 3 cannot be divided evenly by 2, we write 3 back. 2 in 4, we write what? 2. And you can see we have 1, 3, 2. We know that 2 can still go. So 2 in 1. Since 1 cannot be divided evenly by 1, since 1 cannot be divided evenly by 2, we write 1 back. 2 in 3. Since 3 cannot be divided evenly by 2, we write 3 back. 2 in 2, that's 1. 3, what do we need to do? We have 1, 3, and 1. So we just need to look for any number that can divide the whole of this thing in order for us to have a common base of 1, 1, 1. So what do we do? 3 in 1. 1 divided by 3, that's 1. Since 1 cannot be divided evenly by 3, 3 in 3, that's 1, and 3 in 1, since 1 cannot be divided evenly by 3, we write 1 back. So what do we do to get the LCM? You simply multiply the whole of this together. That's 2 times 2 for 4 times 2 is 8 times 3. That's going to give you what? 24. So you can see this is exactly how you solve what? LCM. So we need to understand some basic things, that whenever you are given a number to look for the LCM, the first thing you need to do is what? Look for any number that can either divide some of the number, maybe like 2 and 6. Maybe this place were to be 9 now. You know that 2 cannot divide 9, but 2 can divide 2 and 6. So you are going to use that number first to divide, and so on and so on and so forth. So you can see, for example, here, you see that we have 2, 9, and 5. So let me just give you a quick tip here. Whenever you see that everything is prime number, just multiply everything together in case you're under tough exam timing, like I would call it. So whenever you see that what everything is prime number, just multiply everything together, you get the LCM. But don't do this when you have what even number, like, or when you have what any number that what that can be divided by other numbers, only prime numbers alone. So you can see we have 3, 9, 12. So you don't say because of 3 is prime number, now you now multiply everything together. No, 9 is not a prime number and 12 is not a prime number. So you can't follow that process. You can only use that process when everything is a prime number. So that's just another tip I want to give out really quick. So the major thing you need to understand is that when you look for the LCM, you look for what can do what can divide evenly into either everything or part of it, and you start. And once you see that you have something like 1 or any number that cannot be divided by this one, you write that number back. Just like we say 1 in 3, 1 cannot be divided evenly by 3, or 3 in 1, sorry, 1 cannot be divided evenly by 3, so we write 1 back, and so on and so forth. So if you know you don't understand, just watch this video, but make sure you subscribe, because I'll be making subsequent video on this same topic in order to ensure that you understand what the principle behind looking for the LCM. So that's all I have for you. I'll see you in the next video. Thank you.